Hello everybody. Let's wait for a few minutes for the others. Have you read the announcement? Can you hear me, Elijah? Trinos. Yep. Mariela. Okay, so in about 5 minutes we'll start our discussion. So how's everybody? So are you now at home? By the way, what are you using? Are you using the mobile devices or your laptop or desktop? So you can use your desktop. Who is using desktop or laptop? Okay, so good because last time my students cannot use the desktop, so I think they fix it now. So you have an option to use your desktop or your mobile device or laptop. Alright, good afternoon class. Good afternoon class.
Afternoon po.
Okay, so hope everybody is already here. So how's everyone? So are you now at your home? Okay, so for the latecomers, please kindly read your notes on your pen. Now, I'll be mentioning some important information or concept that might not be seen in your notes, the uploaded notes. So better write down some important points. Okay? Alright, so I know that it's been about 2 weeks already that we have discussed the introductory part of our lesson. So this time we're going to review those parts of our discussion last time. Are you ready now? So we'll begin again with the parts that we have discussed before, but it's a little bit faster. Magre-review lang tayo what we had discussed last time para ma-connect natin sa next topic. Okay? So last time we talked about this introduction of our course mechanics. So for this session, our objectives are the following. So at the end of the lesson, you should be able to first is define the basic quantities and fundamental concepts in mechanics and solve with 2 types of units. As discussed before, so we have here the definition of the mechanics is the science which describes and predicts the conditions of rest or motion of bodies under the action of forces. And we have categories of mechanics: the rigid bodies, deformable bodies, and fluids. Then under rigid bodies, we have the statics and dynamics. Or we can see it in this diagram. Okay, so we have here as the main thing, which is the mechanics, and we have here the rigid bodies, and we also have deformable bodies and fluids. So under fluids, we have compressible, incompressible, and we have compressible fluids. But our focus would be on the rigid bodies. So under these rigid bodies, we have the statics and dynamics. So when we speak of statics, so we consider the bodies at rest, and for dynamics, we consider the bodies in motion. All right. In statics, so both the resultant force and the resultant moment of force are zero. So you have to remember that principle. Thus, establishing the equations of equilibrium, because resultant, that is for the force and the resultant moment of the force, they are zero. In dynamics, however, the resultant force and moments are not zero, and therefore it causes a change in the state of motion of the body on which they act. So the body in consideration is assumed to be rigid, and the resultant force couple system is applied at the center of gravity of the body. Now when we speak of dynamics, so dynamics includes kinematics and kinetics. So when we speak of kinetics, this is a study of geometry of motion. So kinematics is used to relate displacement, velocity, acceleration, and time without reference to the cause of motion. On the other hand, kinematics is a study of the relations existing between the forces acting on a body, the mass of the body, and the motion of the body. Kinetics is used to predict the motion caused by the given forces, or to determine the forces required to produce a given motion. And we have here what we call particle. So this time I hope you open your mind to this new concept of particle. So in this context, particle does not indicate the smallness of size. Rather, it means that the shape and size of the body do not significantly affect the solution of the problem under consideration. Alright? Then we have motion of a particle. So what does it mean, motion of a particle? So we have what we call the rectilinear motion. So in this particular motion, the direction of resultant is constant. The motion of a particle is along a straight path and is called rectilinear translation. And we also have another motion, that is what we call curvilinear motion, where the motion of a particle is along a curved line in 2 or 3 dimensions. Alright? Now we have systems of units. So we have kinetic units, that is the length, time, mass, and force. 3 of the kinetic units referred to as basic units. and may be defined arbitrarily. And the fourth unit referred to as a derived unit and must have a definition compatible with Newton's second law of motion, which is given in this formula, that the force, the vectorial force, is equal to the mass times the acceleration. So by the way, kung yung nakita nyo dyan sa taas ng F, that is an arrow, no? An arrow going to the right, so that indicates direction. Okay, yeah, that one. Okay, so hindi lang na convert properly, no? So this part here, so this indicates direction. This is an arrow supposedly. All right, so force, by the way, we have what we call International System of Units, or SI units. So the basic units are length, time, and mass, which are arbitrarily defined as the meter for the length, seconds for the time, and kilogram for the mass. So force is the derived unit. Now we have here F is equal to ma, so we can derive the force as 1 Newton is equal to 1 kilogram 1 meter per second squared. So ito yung equivalent ng Newton, 1 Newton, that is 1 kilogram meter per second squared. Okay? Then we have US customary units. So the basic units are, again, length, time, and force, which are arbitrarily defined as foot, seconds, and pounds. And mass is the derived units. So we have M equal to F over A. Force divided by the acceleration. And we have here a unit what we call slug. And 1 slug is equal to 1 pound per 1 foot per second squared. Okay, so I hope you remember now what we had discussed last time. And we have here the symbols and abbreviations of system of units or systems of units. So I'm just checking, no, if you're still awake. Hi, Mr. Bundok. So for this problem, which of the formulas? Hi, Crystal. Where are you going? Another problem. Emma Harian is approaching a stoplight, moving with a velocity of 30 meters per second. The light turns yellow, and Emma applies the brakes and skids to a stop. If Emma's acceleration is negative 8 meter per second squared, then determine the displacement of the car during the skidding process. Okay, so how will we solve this problem? Which of the formula shall we use? Okay, so for this problem, we will use the third formula. Okay, that's correct. Now, so we are in the third formula, we have v squared equal to initial velocity squared plus twice the product of acceleration and the displacement. And you substitute the given, then you'll get the displacement that is equal to 56.3 meters. Alright? So the next problem, an engineer is designing the runway for an airport. Of the planes that will use the airport, the lowest acceleration rate is likely to be 3 meters per second squared. The takeoff speed for this plane will be 65 meters per second. Assuming this minimum acceleration, what is the minimum allowed length for the runway? Again, we have the answers there, or the answer. Now the question is, which of the formula shall we use? Alright, so that's the same, third formula. So applying that third formula, now we're given what are givens? We have the acceleration, we have the acceleration given. So what is that 65 meters per second? That is the velocity, right? Now we are asked to determine the minimum allowed length for the runway. So it means that we are going to find how long, or the length of the runway. That is the minimum, the shortest length that can be constructed. Alright, so the answer is 704 meters. Okay, so I think that's, anyway, this is just a review of what you had learned before. Now, next problem. So, next problem, class. Rocket-powered slides are used to test the human response to acceleration. If a rocket-powered sled is accelerated to a speed of 444 meters per second in 1.83 seconds, then what is the acceleration and what is the distance that the sled travels? So, which of the formula shall we use? Other answer? Are you sure? Are you sure? Yep.
Sure, yep.
So there are two requirements here. We are asked to solve for the acceleration and also the displacement. Anybody? Hi, Mariela. So, what's your answer? Which of the formula shall you use?
Which of the formula shall you use?
Wait lang po.
So, tatlo lang yung formula, ha? So, for the first answer, so ano yung gagamitin natin?
Yung first formula po sa unang tinatanong po.
Then how about the second one? So to calculate the displacement.
Calculate the
Yung sa pangalawa pong tinatanong,
Hmm.
yung second formula po.
Alright. Yung una.
right? Yung una.
Yung first formula po.
Okay. So thank you very much, Mariela.
Thank you very much.
So that's how easy, no? Next. How about this problem? So next problem is, if Michael Jordan has a vertical leap of 1.29 meter, then what is his takeoff speed and his hang time, or that is the total time move upwards to the peak and then returns to the ground? So again, for this problem we have two requirements. Anong ibig sabihin yan, class, na take-off speed? What does it mean? Anybody? What do you understand with this statement, take-off speed? Be the initial speed. Okay? So which of the formulas shall we use? For the first problem, so for the takeoff speed, which formula shall we use? Anybody? So how about the others? What's your answer? Which of the formula shall we use to calculate the initial velocity? Okay, so to calculate the initial velocity, we need to use the third formula. Alright, that's correct. How about the second problem here? That is the total, or the hang-up time. For the hang-up time, we have to use the first, second, or third. So hang-up time, class, that is the total time to move upwards to the peak and then returns to the ground. It means that initially, when Michael Jordan takes off until he reaches the highest point and then returns to the ground. So that is the total time. So again, which of the formulas? Mariela, what's the formula? For the second question.
First formula po.
For the first question, which formula to calculate the hang-up time or hang time? Can you again, everyone, can you type again your names? Okay, thank you. James. So what's formula, James? James, which of the formula shall we use? So how will you calculate the secant problem? Anybody? Hi Lee. So how will you calculate the secant problem, Lee? Okay, secant formula and then what? So nasa tatlong formulas lang yun ha. If you cannot answer it now, so try to explore it. So baka ito yung ibibigay ko sa exam ninyo. No, a car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meters. Determine the acceleration of the car. So which of the formulas shall we use? Olais.
Sir, second formula po.
Okay, thank you very much. Alright, so that's how easy class now, this part. So this is just an introductory part of our course, and hope everyone understood it. So don't forget those principles of the lessons. You should be able to solve with two types of units. Problems with two types of units. The other one is derive the different equations used for particles in rectilinear motion and apply this derived equation in solving uniform and uniformly accelerated rectilinear motion problems. Then next is apply graphing techniques in solving rectilinear motion problems and apply integration techniques in solving rectilinear motion problems. So in other words, class, for this part, now we have problems in rectilinear motion, and we will solve them in different ways. Now we can use the graphing method or the integration techniques. Alright? Here we have an illustration. So particle moving along a straight line is said to be in rectilinear motion. As you can see from this graph, now this is the origin. This is where the particle position at t equal to 0, and then at a certain time it moves to this direction, and now positioning at point P with a distance from its original position, that is x. So by the way, one of this, the measurement here is 1 meter. So between the two vertical lines, small vertical lines, so that is 1 meter. So we have here what we call position coordinate. So when we speak of position coordinate, so we have here this now a line, horizontal line. Okay, so position coordinate of a particle is defined by positive or negative distance of a particle from a fixed origin on the line. So in this illustration, we have here the origin at O, point O. So going to the right, so we consider this as positive. Going to the left, we consider it as negative. Then the motion of a particle is known if the position coordinate of particle is known for every value of time. So motion of particle may be expressed in the form of a function that is given in this equation here. X sub t equals x sub t equals 6t squared minus t cubed, or it can be in the form of a graph that is x in terms of meter versus time in terms of seconds, as you can see from this graph below, the color blue. Okay, any question on this part, class? So we have here an x expressed as a function of time. Alright, so this is the position of particle as a function of time. So given as 60 squared minus t cubed, when you graph this one, you will see this curve, the blue color curve. Okay, so for the next slide, so again, our conclusion here is that the instantaneous velocity may be positive or negative, and magnitude of velocity is referred to as particle speed. So we call it particle speed. Instantaneous velocity is equal to the limit of the ratio of the change of the displacement with respect to time, or we have delta x, delta t, as delta t approaches to 0. In our differential calculus, we express this limit of this ratio as delta t approaches to 0 as dx over dt. Right, so this is the derivative of x with respect to time. The derivative of the distance with respect to time. So again, so take note that the instantaneous velocity is equal to the limit of delta x with respect to time, delta t, as delta t approaches to 0, and this is expressed as dx over dt. So we can rewrite it, instead of writing limits of this ratio as delta t approaches to 0, we can say v is equal to dx over dt. So we can determine the instantaneous speed of the particle by taking the derivative of the distance traveled by the particle with respect to time. Okay, so for example, if you are given the distance traveled by our particle expressed as a function of time, so we have x sub t, or x as a function of t, equal to 6t squared minus t cubed. So to solve for the speed, okay, so we just take the derivative of x with respect to t. So we have here dx over dt, that is equal to, from our calculus, so these two here, the exponent will go down, then multiplied by 6. So that's why we have here 12t. Then the exponent 2 minus 1, so that becomes t to the power 1, or simply t. Then the other term, we have t cubed. So derivative of t cubed with respect to t is 3t squared. So we have now the velocity as a function of time equivalent to 12t minus 3t squared. Okay? Is that clear?
Yes po.
Alright, sorry class, we have no time. We'll continue this discussion in our next session next time. Alright? So now I will check your attendance. So don't leave yet, because I have some more. Kindly type your names again so I can see it on the screen. I'm recording it and you can check it later on to verify your attendance. So I see initially 27 but now only 23. So the rest leave earlier. So I consider only those who are present. No, I check your attendance I think 3 times. So if you miss one of this attendance, then you're considered as partially absent. So take note, in our arrangement before, you have 100 points. Alright, so every time you're absent, so that is minus 10. Or 3 times you are tardy, you're late, that's considered 1 absent. I hope you still remember that arrangement, class. Okay, how about the rest? Where are the others? Oh, just joined. So where were you, Ralph? Where were you a while ago, Elijah? So just come because we're checking attendance.
Sir, hindi ko
Okay, so I'll check attendance, Okay, say present when I call your name. Almeida. Richard Almeida. Absent. Alvarez. No, you just say present if you're around.
present, Sir Alvarez.
Okay, say Almeida. Absent. Apigo. Cristel. Absent also. Aquino. Say present, Aquino, if you're around. Oh, narinig kita. So Aquino present. RCO absent. Almeida.
Sir, yung Almeida present po.
Si Almeida present. Yes, hold on.
Tsaka yung Aquino, sir.
Yes, Aquino, yes. How about si RCO? RCO absent? Okay, RCO absent. Asorpado. Shadow absent. Banikid absent. Joshua Bautista
Present po, sir.
Buado absent. Bundok Bungais Jan Bungais Absent. Bundok Jordan. Sino yung bundok na present? Si Jordan or si Merjan? Si Merjan, so si Jordan absent. Zaira. Kamu Zaira? Absent. Kaparas. Kaparas. Castillo.
Present.
Okay. Concoles. Concoles absent. Dalhag. Dalhag. Present. Noel Dalhag. Absent, ha? Dano. Dano, Russell. Hana. Absent. De La Piña. Say present, ha, if you are present. If you are not, De La Piña.
Present, sir.
Del Mundo. Say present, Del Mundo, if you're present. Sira ang mic.
Mike.
Ispilita.
Present po, sir.
Falan. Aislinn. Absent. Gonzales.
Present po. Present po, sir.
Okay. Jose, Mariela.
Present po, sir.
So check your ano, ha, I'll post the
I'll post
the link of the
link of the
video where we have the lesson. So access that one and check your names if you are present or absent. So the video that I'm taking while doing this lecture will prove that you're around or you're absent. Lakatan. Absent. Mago absent. Manaig absent. I can double check this one because when I look at the numbers, it was 27, it becomes 23. So you have to check, ha, if your names are correctly considered present or absent. Adrian Montalban.
Present, sir.
Okay. How about
Sir, present mo na equal.
Manaig? Okay.
No, sir.
No good.
Sir.
No good. So I'm checking attendance sa Manaig. You are not listening. How much more sa lesson natin kanina? No good. Absent. Ulais Lee. Orbi. Christian Orbi. Absent. Pagaspas absent. Pagaspas present, absent. Si Orbi. Okay, present si Orbi. How about Palaganas?
Present po, sir.
Okay, Palaganas present. Rasi, right? Race, Kayla? Kayla? Present, absent? Rodriguez?
Present po, sir.
Okay. Salvador? Sabalvaro? Sabalvaro? Absent? Simanya?
Present po, sir.
Trinos? Please say present para mabilis tayo. Trinos? See present kung around ha, if you're around. Kasi pag I will look at your message, it will take us more time. Erika,
Sir, present.
Vicente, Micaela,
Present po. Present po.
Patrick Villanueva. Okay, absent ha. Villeros, absent. Yap, Villeros present. Yap, type your name. Yap, type your name on the screen. Yap, type your name.
For the floor po.
Si Yap, present, absent.
Yes, present, sir.
Okay, class, I'm not so sure no, if I've taken your attendance properly. You just check ha. I'll send you the link